Math Made Easy, Take 5. Today we're going to be talking about scientific notation. Scientific notation is a way that we can write real big numbers or real small numbers without having to take up so much space. This is particularly useful in the science field where you might have a really big number or a really small number and you don't want to waste a lot of time writing it over and over and over and taking so much time to make sure that you get it correct. So let's go ahead and jump into our notes. So first thing, scientific notation is a short way to write very big or very small numbers. To convert from scientific notation to standard notation, and that's the way we normally write numbers. We just read the exponent, the small number at the top. To determine how many spaces, we move the decimal. If the exponent is positive, it will be a big number. So we will move the decimal to the right. If the exponent is negative, that means it'll be a small number. So we will move the decimal to the left. So let's take an example. So here they gave us this number. First thing I'm going to do is I'm going to ask myself, all right, where's the exponent, the number at the top? So it's a 3. That tells me how many spaces I need to move my decimal point. Since it's positive, that means move to the right. And since it's 3, that's my number of spaces. So what I'm going to do is I'm going to go ahead and first find my decimal. I'm going to move it 3 spots. 1, 2, 3. That's where my new decimal is. I'm going to copy it over. Noticing, I could have also written it like this, but I don't need to. Now I'm done. This was scientific, and this is standard. Scientific means I have times 10 to the power of something. Standard means just the normal way that I write my numbers. All right, so let's see. Surface area of Earth is this much, and they want me to change this to standard notation. All right, so first let me go ahead and write this over. Okay, so let me go ahead and find my exponent. It's an 8. So that's positive. That means I'm going to the right, so I should make a big number. And it's 8, which is my number of spaces. So I'm going to take just the number. Okay. Now I'm going to go ahead and I'm going to find where my decimal is at. I'm going to put an X there. I'm going to move 8 spaces to the right. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So now I have it. That's where my decimal should be now. But wait a second. Something's weird here. There's a whole bunch of blank spaces. What do I do with that? Well, I can go ahead and just fill those in with zeros. So my new number should look like this. Noticing that it would probably be a lot easier to keep that as scientific notation instead of standard form, because I had to make sure I was counting all of my zeros to make sure that I was correct. So let me go ahead and clear this up so we can get some more space. All right, next one. 1.5 times 10 to the power of negative 5. Well, look at that. This one's negative. That means I go to the left, and it also means that it's a small number. The 5 means 5 spaces. All right, so let me go ahead and just rewrite my number. I'm going to find my decimal, and I'm going to move 5 spaces left. 1, 2, 3, 4, 5. All right, so that's where my decimal is. Everywhere that I created a space, I'm going to go ahead and put 0. I'm going to go ahead and rewrite that. And there's my answer. Now in standard notation. Noticing that it still would have been so much easier just to leave it in scientific notation, because sometimes I might forget to put a 0 or I might put an extra 0. All right, example number 4. A scientist measures the mass of an atom and finds that it is this many grams. How is the mass of the atom expressed in standard notation? So for a split second here, I want to deviate and just talk about how we're supposed to read this. So I would say 3.4 times 10 to the power of negative 8 grams. Again, 3.4 times 10 to the power of negative 8 grams. Okay, so I need to change this to standard notation. All right, first things first. Let me go ahead and look at that exponent, the number at the top. It's negative, so this is a small number, and it's also going to the left. 8 is my number of spaces. So let me go ahead and copy my number over. And let me give myself a little bit extra room here. 3.4, put my X. Let's go ahead and move 8 spaces to the left. 1, 2, 3, 4, 5, 6, 7, 8. All right, here is my new decimal point. 1, 2, 3, 4, 5, 6, 7. I'm starting to notice a pattern here. Interesting. Okay. 1, 2, 3, 4, 5, 6, 7, 3, 4. Noticing again, if we compare these two numbers, it looks like scientific notation is going to be a lot easier to write. Okay, but what about the case whenever they give us a regular number and they want us to change it to scientific notation? So something like this guy, right? What's the process for that? Well, it's exactly the opposite. So in order for us to go from standard notation to scientific notation, first thing we need to do is highlight where the decimal is in the number. And then we're going to move the decimal either to the far right or the far left so that it is in front of the second number. And the new number that we make is less than 10, but greater than 1. So that means our scientific notation number should be bigger than 1, smaller than 10. Count the number of spaces. You move the decimal, and that will be your exponent. Okay, so let's take a look at this first example. So first thing, I'm looking at this and I say, okay, is that a big number, small number? That's a big number. So it should be positive. Okay, now I'm going to identify where my decimal is. Well, I don't see one here. I don't see a decimal. So where could it be? Well, if you don't see one, it's right there at the very end. They just didn't write it. Because technically this is 2,500,000.00000, right? So we know that our decimal is at the very end. So now I'm going to look to see where can I put my decimal in between two numbers that will give me a number in between 1 and 10. It's got to be bigger than 1, smaller than 10. Okay, so I'm going to say, well, let's do a couple of trials here. No, still bigger than 10. Okay, keep going, keep going. Now look at that, 2.5. That's bigger than 1, smaller than 10. Okay, so it fits. Let me count how many spaces I'd have to move to do that. 1, 2, 3, 4, 5, 6. 6 spaces. Okay, so now I'm going to copy that number over. 2.5 times 10 to the power of 6. And because it was a big number, it's positive, but we really don't need to write that. But I wrote it just because. So this is our number in scientific notation. Noticing that 2,500,000 is a lot easier to write as 2.5 times 10 to the power of 6. All right. So Americans eat an average of 100 acres of pizza per year. That is equivalent to this many square feet of pizza per year. How is this area expressed using scientific notation? Well, first let me go ahead and rewrite my number. Okay, so I have my number. First thing I'm going to ask myself, is this big or small? Well, this is definitely a big number. So that means that my exponent is going to be positive. Now I'm going to go ahead and say, all right, where's my decimal? I don't see one, so it's got to be at the end. Now I'm going to look to see where I can put decimals in between two numbers. That'll give me a number in between 1 and 10. Now, the number, where you're going to move the decimal is always going to be either way over to the left or way over to the right. So I'm going to skip over all those trials. I'm going to look over here. I'm going to put it in between the first and the second number. 4.356. Is that bigger than 1? Yeah. Is it smaller than 10? Yes. All right, good. So I'm going to go ahead and rewrite it after I count. 3, 4, 5, 6. 4.356 times 10 to the power of positive 6, which we don't have to write the positive. That means that 4,356,000 is the same thing as 4.356 times 10 to the power of 6. Okay, good. Let's go ahead and keep looking. So here I see this number. Wait a second, that decimal's way in the front. So I see this number, and this is really small. So that means that I'm probably going to have a negative exponent. Now I'm going to go ahead and identify my decimal. It's right here at the beginning. So let me go ahead and check to see where I can put my decimal. So let me zoom in just a little bit here. So no, yes. Okay, so 8.009. That makes a number that's bigger than 1 and smaller than 10. But what about if I had put it, no, that's 800.9. That's way. So that's where I should move it. Let me count. 1, 2, 3, 4, 5. 5 spaces. So this should be 8.009 times 10 to the power of negative 5. Noticing I have to write my negative. And that looks much easier to write than the way that they had it before. All right, let's look at one more example. So the diameter of a grain of sand is approximately this many inches. I need to write it in scientific notation. Okay, so I have this. First thing is a small number. So it's going to be a negative exponent. So now I'm going to look for my decimal. I'm going to look for a place to put it to get a number in between 1 and 10. All right, there we go, 2.4. 1, 2, 3. That's 3 spaces. So I get 2.4 times 10 to the power of 3, but because it was a small number, negative. Remembering I absolutely have to write in my negative. All right, thanks so much for paying attention. Make sure that you do these questions below, and I will see you next time. Bye.